I hope you are all well. Welcome to this short session on soil drainage. In other words, all the pipes and fittings in the ground. Above the ground, the pipes, etc., are referred to are sanitary plumbing. The exercise that we are going to do is the small building. This is the site, that is the building itself. And then we have the piping from a gully, from the vent pipe going that direction. And from there, it goes down into the municipal inspection chamber, right? And there it's all the depths are indicated. And the depth, the rodding eye there's an inspection eye. There is the rodding eye too. Okay, if we look at the dimensions and the descriptions, it is under a heading of soil drainage, and there is our very first description. However, let's look at the drawing first. What is given is the depth at the rodding eye, the invert level thereof, at that point there, that is at the top. So that is the actual bottom of the pipe. In other words, at that point, the depth is 600. At that point there, it is 725 millimeter. I have scaled the dimensions and I've indicated that in red. In other words, I've scaled from the middle point of the gully to the middle point of that horizontal line, and the length is 1.3. Similarly, for that pipe at the bottom of the vent pipe, from the middle of the vent pipe to the middle of the horizontal pipe there, it is also a length of 1,300. The scaled length from that point over there to the inspection eye is 1.35, and the length from IE1 to that rodding eye 2 is 4 meters. Secondly, if we look at the other lengths, just for scaling purposes, that length there, from that point going down to the rodding eye 2 is a total of 12.55. So those are the lengths that I am going to use for all my calculation purposes. The depth at that point there is 600. The depth at that point, 725. Now we need to determine the approximate depth at that point there. The way I've determined that is the total length from there to there is the 5.35. If I take that portion in proportion to that portion there, in other words, 1350 divided by the total length, I see that that is almost a quarter, 0.25. So that length is almost a quarter of that length there. The depth at that point is 600. The depth at that point is 725. So the difference between those two is 125 millimeter. So of that 125, if I take a quarter of that, I get 31 millimeter. So let's say 30 millimeter. So from that point there, it drops down by 30 millimeter. So the depth at that point there is the 600 plus the 30 millimeter. So that gives me 630 millimeter. That's how I determine the depths at those points. So now if we can go back to our descriptions, 110 millimeter UPVC pipe laid in and including trenches, not exceeding 1 meter deep, or those depths less than 1 meter. The first one there is that length, two lengths of 1.30 times 2, and the reference there is from the building to rodding eye 1, and from the building to IE1, 1.3 times 2. The next length is that 1.35. Note we have to scale it from that point to that point there. That part is the part going up to the rotting eye at that angle of 45 degrees. So from there to there is the 1.35. It is from rotting eye 1 to IE1. The next length then is that in green, that 4 meters from rotting eye 1 to rotting eye 2. Then we get to this length of pipe, which we have to split into 2, because the pipe at that point is 725, and at the next rotting eye, it is 1030. So somewhere along the line, we will have the split between the 1 meter, not exceeding 1 meter, and then exceeding 1 meter, not exceeding 2 meters deep. And there I've done the calculation. We've done this previously. How do we calculate the total length of not exceeding 1 meter, that length there, and the other length of exceeding 1 meter, not exceeding 2 meter deep? I think you are familiar with that method. And using that method there, I've seen that the section of not exceeding 1 meter deep is that 11.32. So that is the dimension from rotting eye 2 to rotting eye 3. Then we go to the next description, ditto about exceeding 1 meter, not exceeding 2 meter deep. And that then is the remainder, in other words, that 1.23, in other words, that short section there from the rotting eye 2 to rotting eye 3, and there is the length of 1.23. Then from rotting eye 3 to the connection point, in other words, that point from there to the municipal inspection chamber, that length there of 2.5 meters. So that is that length there. The next description is for those pipes raking to inspection eyes. In other words, at the various points, at that rotting eye 3, because that's what it looks like there. That pipe going down, so now we need to determine the length of that pipe there. Similarly, we need to determine the length, that slope length, and that slope length over there. And to determine that, at rotting eye 1, we take the depth as 600, because we work with a 45-degree triangle. We use the formula 600 square plus 600 square, and we take the square root thereof to get the 0.85. Similarly, at rotting eye number 2, we take the 725, and we take the square root of that to get to the 1.03. And similarly, for the last rotting eye, at that point there, which is 1030, we need to determine that length, and that is then the 1.46. There you can actually see what that looks like. It is that pipe going down. Just ignore that, please. Pipe going down into that pipe, horizontal pipe. Then we can go on to all the extras. Now, if we look at this drawing, let's explain where we have junctions, where we have IE junctions, etc. The important thing is that it must be at all times possible to clean all pipes. In other words, if there's a blockage in that length of pipe, we need to be able to clean that pipe. And this is what they normally use. They've got those steel rods which can be joined together depending on the length of the pipe. And then at the end of the pipe, they have these fittings that is used to then clean whatever is in the pipe blocking that pipe. So they use that. So, for example, if there's a blockage in that length of pipe, there must be a way of cleaning that pipe. And in this instance, we have that rotting eye so they can clean that pipe from that point onwards. If we look at this length of pipe, we have that rotting eye over there, so we can clean it there. And in this instance, there's also a rotting eye at that point there, so that these lengths do not become too long. So we have another rotting eye there to clean this length of pipe. Right, so then the remaining pipes are those two pipes that need to be cleaned. At that point there, we cannot clean it because there's a gully. So to clean that length of pipe, we need some sort of a fitting there. And what they're going to use there is an IE junction so that they can clean that length of pipe if they have an IE at that point. That's why at that point there, we have that IE junction. And obviously we have a bend there as well. That bend over there at the bottom of rotting eyes. And there is that IE junction that you see, right? If we go back there, at that point there, we will have an IE junction and we have that bend. Similarly, to clean this length of pipe, we have that IE there. So in other words, that there will be an IE junction at that point, and we have that precast concrete marker block. At that point there, we have a gully trap, and that's what that looks like. Right, there's the gully, so the pipe going down. We've got the trap at the bottom, and then you've got your horizontal drain pipe. There's the gully at the top, and there is your P-trap. So there we do not have to measure any bends at that point there. Gully is measured, that fitting and the pipe and that bend at the bottom, it become part of the description for that gully trap. So there we do not have to measure an extra bend. At that point, however, we need a bend to join the vertical pipe against the building to that horizontal. It does not have to be an IE bend because we're going to clean that length of pipe from that point. If we look at this junction over there, there's the bend at the bottom of the pipe. In other words, that bend there. And then we have this junction or this length of pipe meeting up with that point there. And there is the detail of that. There's our junction. It is a normal junction because we can clean that length of pipe from that rotting iron. But to join that pipe to this pipe, we also need a bend in that position there, because this junction, the branch is also always at an angle of 45 degrees. So that's why at that point, we also need a bend. So that's the fitting at that point there. If we go down to that point there, we have the horizontal pipe, and then we have the rotting eye at that point, so we can clean that length of pipe. So that junction there does not have to be an IE junction because it can be cleaned. So that's all the fittings at the various points needed. So if we go back to our dimensions, first one, extra over UPVC pipes for 110 millimeter bend. We have one building bend pipe. So there is that bend over there at that point there. So let's mark that one off. We have two bends, a rotting eye 1 and 2. That is that bend over there and that bend over there. Right? So those two bends. And then we also have a bend at a rotting eye 2, that bend over there, that one over there. The previous one, we have that bend at that point and that point. But at that point, we have an extra bend indicated there. So that is that one at rotting eye number 2. If you do the next one is your 110 millimeter junctions. You can see we have a junction over there. Those ones are IE junction. So that is that junction in that position. So at rodding eye number 2, and the other one is that junction there. It is a normal junction, not an IE junction. So those two junctions. Then access junctions, we've got one at rodding eye 1, access junction. All right. So it is that one there, access junction there, and we have that IE junction in that position. So that's why we've got one there at rodding I1 and also one at IE1. One there and one there. Ditto, but 110 millimeter rodding eye cover in end of pipe. It is just that fitting that we have in that position there. In that position there, we've got those rodding eye covers. In other words, we've got at each of the rodding eyes, we have a rodding eye cover in the end of the pipe. The next item is the gully. The way we measure gullies is standard system clause. Simply says it's measured in number. In the standard system, there is no depth increments, but obviously the depth of the gully will determine the length of pipe needed. So to compensate for that or to allow for that, we have categories, and those are just categories that's used in the profession. It's not in the standard system. So we use those 500 millimeter increments for gullies. If you look at our gullies, that gully, the depth there is 570 millimeter. Sorry, just by the way, how did I determine that depth and that depth there? I've just used that depth of 600 millimeter at that point. At a fall of 140 millimeter, the depth at that point there is 570. You can do the calculation. I've used 1 in 40. Similarly, for that one, the depth there is 630. And at calculate, it gets a depth there of 600 millimeter. So for the gully, the depth increments or the category will be 500 to 1000 millimeter deep gully. And there's one gully in that position. And that is that dimension for our gully. Sorry, it's got to be in that position. Then we also have that precast concrete inspection eye marker, which we will have in that point there to indicate where that eye is. There's no pipe from the ground down to the drain pipe, so they need to know where that eye is in that precast concrete marker block. Then they will put in that position above the ground, and we simply have one of them. And then the second last item is the allowance for soft rock and for hard rock. And the rule there is in accordance with the standard system. We allow 110 millimeter plus 300 millimeter on both sides of the pipe. So the width of the trench for pipes not exceeding 1 meter deep will be 710 millimeter wide. And we increase that by 700 millimeter for each successive depth. So for 1 to 2 meters, it will be 810 millimeter wide. Then I've just reused all the lengths that I've used for my pipes. So the first one is that 1.3, and to calculate the depth, we take the average of the 600 and the 570 millimeter. So it is the average of the 600 and 570 millimeter. And then we add 100 millimeter bedding at the bottom, will give us then a depth of 0.69. So it is that first one from the building to a rodding I1. Similarly, for that one from the vent pipe to IE1, it is the average of the 600 and the 630. So the average of the 600 and 630 divided by 2 plus the 100 will give us a total dimension there of 0.72. Then from rodding I1 to that point there, a length of 1.35, the average of the 600 and the 630, that one over there, that gives us a total width of, a depth of 0.72, and that is that length there. From IE1 to rodding I2, in other words, that 4-meter length of pipe, the average of 630 and 725, that one there will give us a depth of 0.78, that one there. The 11.32, in other words, the average of the 7.25, and at that point there, it is 1 meter. So it is the average of the 725 plus 1 meter, gives us a depth of 0.96, with that dimension rodding I2 to 3. And then the last two is then the length from the 1 meter to the 1.03. 1 meter, 1.03 will give us a total there of 1.12. And just take note there, the width now becomes 0.81 for that dimension. And then the last section is that 2.5 meter, average of 1030 and 1050. The length 2.5, the width 0.81, and the depth is the average of the 1030 and the 1050, 1030, 1050, and giving us then a depth of 1.14. In the testing of the item, drainage system, there's an item. Then we also have connection to the municipal inspection chamber, allow a provisional sum, and we also allow profit for the main contractor, so that there is just a provisional sum. Right, ladies and gentlemen, that is the end of this session on soil drainage. I hope you've enjoyed it. Thank you and goodbye.